about. So this is augmenting human creativity with automated text generation, as you've already seen. Okay, so let me start with just giving some of the research context and the terminology that's associated with the topic that that is associated with this talk and what I've been working on. So computers that model human behavior, that is a general definition for artificial intelligence or AI. And also you might hear the term machine learning associated with this. Machine learning, in the context of this talk, you can just think about as a particular approach to AI. So computers that model human creativity, that often goes by the name of computational creativity. And then computers that model human language, this is often referred to as natural language processing or NLP. And it's the intersection between these two things inside this umbrella of AI where I have focused most of my work. So the term you might hear most commonly is creative language generation, or also story generation is something that also comes out of this. So I just want to frame that as far as like if you are reading papers in AI or seeing certain terms, this is where the topic of my work is situated. So then to give you an idea of what is creative language generation using machines, let me just give some examples first. So creative language generation has been applied to pretty much any type of writing that people have produced. So one common one is poetry, getting machines to automatically generate poetry. Along with that, song lyrics, so poetry that's matched with some sort of melody. Slogans, so things that short phrases or segments that are associated with like advertising campaigns where you're trying to persuade someone by being catchy. Word blends, so if you have one or more words and you want to combine them in order to produce a word that's related in meaning to both of them, that can be seen as an instance of linguistic creativity that can also be automated. Puns, so now getting into humor. Humor is also an element of creativity. And along with that, even there's work on automatically generating satirical news. So flash fiction, I already mentioned story generation is one of the focuses of my research. There has been some recent work on taking some sort of writing prompt. So this would be the topic of a story or premise, plot foundation, and then writing or automatically generating a story that pertains to that writing prompt. So within story generation, my work has specifically looked at the task of story continuation. And so I'll be talking about some experiments I did related to this. Story continuation is just an instance of the story generation task where you have some initial story that's already present. So this could be a human authored story up to a certain point. And then the generation task is to predict the next segment in the story. So in this case, the next sentence. And then another thing I'll be talking about here is what can be referred to as idea elaboration. I'll be looking at, or my research is focused on a specific type of this elaboration that I'm referring to as text infilling. So here's an example of the text infilling task. That's also an example of idea elaboration. So if you have some prompt that you're trying to elaborate on, so in this case, a prompt could be just a list of words, then you convert the prompt into an expanded idea, or in this case, an expanded sentence that contains those prompt words. So this is the text infilling task, in that you're infilling words between those prompt words in order to create a sentence. So I'll also be talking about that in a minute. Okay, so those are just some examples to give you an idea of what is automated creative language generation. So that's what's been done in the research field, and there's a lot more opportunity to do other types of language generation as well. So why are computers useful for augmenting human creativity is, of course, a question that we should ask. So there's a researcher, cognitive science researcher named Margaret Bowden. She wrote a book that was pretty foundational in computational creativity called The Creative Mind. And one of the things that she identifies is that human creativity, a huge component of it is that it involves unfamiliar combinations of familiar ideas. So that's one way to look at creativity, or at least certain dominant types of creativity. So this is often a process of serendipity. So by chance, you come across some combination of ideas. So a lot of when you're brainstorming, you're just kind of coming up with various different connections. A lot of those won't necessarily be meaningful. They'll just kind of seem random or chaotic. But in that process, you might find something that is unexpected and yet has value as well. So there is some meaning in making this connection that is novel and unexpected. And how do computers come into play here? Well, computers are really good at simulating combinations. So they can easily produce unexpected combinations. And then as a human, you can judge the creative value of those combinations and as part of the brainstorming process. So that is kind of the proposal for how computers can help aid human creativity. So then I want to talk about, I use the term machine learning that I know some people are already familiar with. It's a general set of approaches in artificial intelligence, definitely the most conventional type of approach in AI right now, but there is a long history of different approaches in AI. But I'll be focusing on machine learning models for text generation because that's what my work has used. So here is a very broad scheme of what a machine learning model for language generation looks like. So you have some input and output. Your input is likely a word or a text, a segment of text, and your output could be another word or another segment of text. And your model encodes the input in a way that enables the model to then predict the output. And everything is represented as large vectors or large sequences of numbers. So that's what the encoding produces, is a set of numbers that represents the input and output, and the input and output as well is all just numbers. So that's the core idea of machine learning, is that you represent everything as continuous values. This is in contrast to some other approaches in AI that focus on discrete logic, for example. But here, for any machine learning model, you're trying to predict an output, and your output here is going to be represented according to some probability distribution over different possible outputs. So this, I'll show, is particularly useful for computational creativity because it means there's many different possible outputs that your model is considering, and some of them have higher probability than others, but it's always allocating some degree of probability to many different outputs. So I'll explain why that's relevant in a second. Okay, so this general model, I'll use an example from story continuation to illustrate how things actually get represented, or how text gets represented in this model. So for story continuation, as I mentioned, you have an input that could be a story up to a certain point. So a set of story sentences. Your model encodes those story sentences in order to make a prediction for the next sentence or segment in the story. So the standard way that this is done, and this applies to all machine learning approaches for language generation, is that the model reads texts. In this case, for story continuation, it reads a bunch of stories, to learn the probabilities of the output segments given the input segments. The segments then get predicted according to these learned probabilities. So that's how they're actually generated, is by sampling from the probability distribution. I'll show an example of that in a second. There's a constant feedback loop to adjust the text encoding, so this middle layer with all of those numbers, in order to make better predictions of the segments. And by better, I mean segments that look like the ones that your model is seeing as it's training. So for example, if you have a story that just consists of a single sentence so far, the child let go of the balloon, you can think of many things that could probably follow this sentence in a story that would be a reasonable continuation. So when your model first sees this, it's seeing this alongside some segment in the text that might be something like the balloon flew away, but it makes an initial prediction and it might not be, it might just produce something like which is not very close to what it's actually seeing in the text. So it needs to adjust this big vector, this encoding, in order to make a better prediction, one that looks more like the balloon flew away. So that's what this feedback loop is. So it gets that feedback that, hey, bring this closer to what I'm actually seeing in the text, and then you get closer. So every time with this feedback loop, your encoding gets updated, your parameters that produce all those numbers, in order to make a prediction that looks more like something you would see in an actual story. Okay, so that's the general process of training, what we call training a model, or the model actually learning how to do this prediction. And then once you have your trained model, the process of generating text is very similar in that you have you're able to use those probabilities to make a prediction once you have your input segment, and you iteratively sample from those learned probabilities in order to generate some segment. And this is a combinatorial process where, because you're iteratively sampling, it means that the generated segments are likely to be novel. So they might look like something that's been seen in a story that your model saw, but it's combinatorial, so there's many different opportunities to sample different things, and that's why you end up with something that looks kind of human authored, but isn't quite exactly what you've seen in a text. That this is a common thing. So here's an example. So if you have that you're trying to generate the continuation after, excuse me, the child let go of the balloon. Let's say you've sampled the, and now you're trying to predict the next word after this. This is the probability distribution that once your model has learned the story text that it might produce. And so you can see that the word balloon, it's probably seen that pretty often in text that looks like this. So it has a pretty high probability score, but you can also see that there's other words here that also have some degree of probability. And when you use a sampling approach to produce the segment, there's always some chance that you're going to sample from something that has a lower probability than the most probable word. So that is the reason that there's a high chance of ending up with something that is a novel segment that isn't directly contained in any human authored text that the model has directly seen. So this relates to the idea of why are computers useful for augmenting human creativity? Well, it's that they can simulate these novel connections that people might not have previously considered. So the novelty is really the value in this type of thing. Okay, so now that was an introduction to the general approach of text generation, especially applied to story continuation, and why it's useful for augmenting human creativity. And now I'm going to talk about some experiments that actually evaluate the value of these models in creative settings. So starting with story continuation, this is work I largely did as a PhD student at USC with my advisor, Andrew Gordon. So to initiate our investigation into story continuation, we started by just building an app that could do this story continuation task. So this app was called Creative Help. There's actually, it still exists on the web. I'll share the link at the end. So this has a very, very simple interface, just a text-based interface where someone is instructed that they can write a story, and then when they want a suggestion for the next sentence in the story or a suggested continuation, they type help. So I'll just read this example just to make it clear. Once there was an adorable black kitty named Opal. She was very fluffy and soft and everyone loved her. Unfortunately, one day while she was coming home from her grandmother's house, she got lost in a dark forest. So this is what a human user of this app has typed so far. And then they requested a suggestion with help. And the system automatically returned, and as she was trying to make her way through the trees. So this was automatically generated. One of the key features of Creative Help was that the user or the author has the upper hand in deciding what to do with the suggestion. That's why it's called a suggestion. So it doesn't have a fixed presence in the story. The users can do whatever they want with it. They can completely delete it, or they can modify it or add to it. And this, as I'll mention in a second, is an important feature for actually trying to evaluate the value of these applications. So for example, then the user saw this automated suggestion and they decided to retain a lot of it, but then add to it a skeleton appeared. So that's just the general interaction of Creative Help. That was the basis for the experiments I did. And one of the key questions here, the key research question that I was trying to investigate through this work is, can we predict the value of generated text to a writer? So you can ask people, when they interact with applications like this, like, oh, what is your experience? How did you like the system? Did you like the text that was being generated? How did it help you? Obviously, those conversations are extremely valuable, but it's also insightful to try to do this analysis quantitatively to get a feel for example, specifically, what did people like in the suggestions? Can we actually quantify the features of the suggestions to figure out what types of suggestions we want to show to people in the future? So that was the research endeavor here. The assumption that we made with our analysis of Creative Help interactions, so we had a bunch of people interact with the system and write stories with it, is that the suggestions that were more helpful to them, the ones that actually they retained, the ones that they found helpful were actually more likely to be retained in the story. So the less a person changes the suggestion, you can make the assumption that they actually liked the suggestion and wanted to use it in their story. And like I said, then that enabled us to look at how the linguistic features of the suggestion predicted its helpfulness. So I'll show an example of this here. So the overall conclusion that we made from this work is that we could actually look at certain features of the suggestions and find that they did predict their helpfulness. So we could analyze this relation in discovering, what do people actually like about the suggestions beyond just them telling us what did they like? What can we see from what they actually did with it in the interaction? So here's an example that looks at one linguistic feature, which is labeled sentiment match here. So there are NLP models that do sentiment analysis, and oftentimes these models will produce some sentiment label such as happy, sad, fearful, surprised, those types of things. So it does this, you can use automated models for this. And that's what we did here, where we looked at, we ran the sentiment model on the initial story here. And in this example, this initial story before the user made the help request was, I picked up the note with trepidation and read in a quavering voice, leave this house, you are in danger. So looking at how the sentiment, the predicted sentiment of that initial story relates to the predicted sentiment of the suggestion. And here the suggestion was, I was shaking and almost in tears. We found that for example, in this case, there's a strong relation between these two sentiment values. The initial story had a high predicted sentiment for fear, and so did the suggestion. And along with that, the helpfulness, the degree of helpfulness of the suggestion was high because the writer decided to retain several of the tokens in the original suggestion, several of the words. And then they just added, they removed one part of a few words from it and then added on the verge of here. So looking at this type of analysis across many different interactions, not just a single one, we overall did find that there was a correlation between the degree to which the sentiment of the initial story and the suggestion matched, and then the helpfulness score. So what we generally can conclude from this is that when a suggestion matches the sentiment of, when the suggestion matched the sentiment of the initial story, in this case, like I said, the sentiment for this particular example is fearful, it tended to be more helpful. So this is just one example of a feature that we looked at. And then there were other linguistic features that also predicted helpfulness as well. And some of them were even as simple as the level of word overlap between the initial story before the help request and then the suggestion. The more overlapping words there were between those two texts, the more the suggestion was likely to be retained. So it's kind of intuitive, but the point of this work was to have a framework where we can actually figure out what is helpful and do this automatically and quickly in a way that actually focuses on the interactions themselves that writers have. Okay, so now I'm going to shift to some of the experiments that I did with text infilling, which is another thing I mentioned earlier. So text infilling, like I said, the text infilling task here is you have some list of words, for example, he, town, rain, that's a list. And you're trying to convert that list of words into a full sentence. So an example of an instance of text infilling given he, town, rain would be he rode his bike to town in the pouring rain. So that's an infilled sentence for the list of words, which I'm calling a prompt. Interestingly, you can actually use the exact same model that was used for story continuation for this text infilling task. It seems like the inputs and outputs are totally different, but actually the interesting thing about these machine learning models is that they're so generic that you can switch out various different types of inputs and outputs and use the same architecture to model these different types of texts. So this diagram looks very similar then to the one I showed for story continuation because it is generally the same type of model. Because this experiment that I did with text infilling is more recent, I made use of a particular model that has come out in the last few years called GPT-2. And you might have heard this term being used in the news because it's gotten, at least with popular science venues, it has gotten a lot of attention for, as I was mentioning at the beginning, producing texts that people can't decide are machine or human generated. So it has tricked a lot of people into producing texts that they actually think are very human-like. So, but all GPT-2 means in this context is it has the same broad scheme as this particular diagram shows. It's just, its uniqueness is in the fact that it has many parameters, and parameters meaning these vectors of numbers that represent the encoding here in this middle layer. There's just, millions of them. And it's also trained, or it's observed millions and millions of documents. So it has a lot of knowledge of language, and that's what gives it some of its power. So, and the other thing with GPT-2 is that it can be tuned for any different task. So the regular, so to speak, GPT-2 has seen a bunch of English text that's on the web. But then you can take that model and plug it into, in this case, the text infilling model, and it will be tuned for that particular task. So in this case, we took GPT-2 and then applied it to a data set that had these pairs, these prompt and infilled sentence pairs in order to get it to specifically perform this text infilling task. So I just want to talk about the experiment that we did to look at text infilling as far as how it relates to augmenting human creativity. So the research question associated with this work was, does observing automatically generated examples of an authoring task, in this case, our authoring task is text infilling, of course, does that help people better perform the text infilling task themselves? So that's what we were trying to get at, can just seeing automatically generated text actually influence the authoring process? So the design here, or the sequence of steps that we did to investigate this, was we first had authors write infilled sentences. So we showed them prompts and had them write unique sentences that contain those words in the prompts. So do the infilling tasks themselves without seeing any generated examples of the infilling task. Then we had our model. Then we had people actually repeat the same infilling task, this time observing generated examples. So we had our model generate a bunch of infilled sentences for the same prompts that the authors saw, and we showed it to them. So we had them repeat the task, write new sentences now that you've seen these generated examples, and that was the post phase. So then after they did that, we gave the resulting sentences to a different set of raters, who then decided which sentences, the pre or post, they liked better. So then that enabled us to have this comparison of the sentences written before observing the generated examples and the sentences written after observing the generated examples. So with the variable here being the actual observation of those examples. So just to make this a little clear, here's the interface during authoring that people saw. So again, you have a prompt, and then in this case, this was the interface at the post stage. So you see these are all automatically generated examples for this prompt. This was hidden in the pre-stage, the initial stage where people just wrote sentences without seeing any examples. And then you have they specifically had to author 2 sentences, so 2 unique sentences they provided. So the ultimate outcome of this work, this task, was that authors wrote more appealing sentences after they observed the generated examples. And this was according to our raters' comparison judgments of the pre and post sentences. And this definitely needs to be further explored. What is the actual impact of the generated text here? This question is definitely something that future work can absolutely be applied to, but one speculation or one interpretation of this result is that the examples might have activated concepts connecting the prompt words that authors did not previously consider. So this goes back to the discussion of creativity being unexpected combinations of familiar ideas. So it might be that the AI generated examples facilitated this process of unexpected combinations that ended up having value. So let me show you a concrete example. This actually comes from the resulting data. So the prompt here, shoulders, waves, color, people had to write an infilled sentence for that. This person wrote a sentence before seeing the generated example. I'm not showing that here, but here then in the post stage, they saw this generated example. His hair was cropped short, flowing down his shoulders, but there were waves of the same color. So that was automatically generated. The author observed that. And then in the post sentence they wrote after seeing this mentioned this conceptual dimension of hair. So her new haircut had the length to the shoulders with waves of a bright pink color all the way down. And I'm not showing the pre-sentence, but that did not have any reference to hair. So we can speculate here that perhaps the effect of the generated example was that it activated this concept that connects the prompt words. Like, oh, hair is something that would be relevant to all of these prompt words. So I can write a sentence pertaining to that. So this is just qualitatively gives you a sense for how the generated text might have influenced people in a way that helped them write more interesting sentences ultimately. So here's some other examples from the infilling model that I find to be particularly interesting. These are not part of any particular experiment, but just some cherry-picked examples where the prompt is actually a term that, as a result of the COVID-19 pandemic, we're all pretty familiar with these phrases on the left. The text that the infilling model that I used in these experiments was trained on did not have any knowledge of the pandemic because all of those texts were published prior to the beginning of the pandemic. So all of these models, and this is kind of an interesting thing with a lot of text generation models that have been released, is that they are not current in the culture and that they don't have this knowledge that now for us is so prominent. So when you provide these phrases that have so much meaning to us to the infilling model, it's really interesting to see how the model reinterprets these things. So it doesn't even recognize, even though we would perceive these as phrases that should appear where the words should appear adjacently in an infilled sentence because it's so hard for us to separate them out. The model doesn't know that. So my favorite is the first one where it's referencing the novel coronavirus as it doesn't know that that's a thing. It thinks that that coronavirus is the title of a novel. And I just really find this fascinating because I think qualitatively it really demonstrates how AI, in not making the same assumptions as us, not having the same conventional constraints in our thinking, it can actually help us overcome and see things in a different way. So these are interpretations that I certainly would not have come up with these types of infilled sentences for these prompts because I'm now so biased to thinking about these things in a particular way. Okay, so that is it for the discussion of the research findings. And here are, so the links for creative help, the story continuation demo is here. And then also there is a demo for the text infilling model that produced those examples that I just showed. So I was told I could share these slides after the talk, so then you guys will have access to these links. I'm now going to show this tutorial very briefly. It's not really a tutorial, it's more just pointing you to a reference in case you are interested in looking further, but I will show some examples of input and output that are associated with this work that I've done, and that's in the GitHub repo here. So let me switch to that. I guess I should maybe I should ask though, are there any questions about the research part of the talk? Because I think we have plenty of time.
It's kind of cool because it's like the thing that your brain should be doing, like making these connections. The computer is kind of doing that for you.
Yeah.
Ways that you're like, oh, I never thought of that. And then that might spark like other connections.
Right.
Never even thought of.
Yeah, and the interesting thing with the infilling task and the particular experiment was that people did not, one thing you could think of as, well, were people just copying the generated output here? Is that why there was a difference between the pre and post sentences? But that actually was definitely not the case because people still preferred the human authored sentences to the generated ones. So we did a comparison, not just of the sentence that was written before seeing the generated examples and the sentence that was written after, but also comparing those to the generated examples themselves. And people definitely favored the ones that were written by people as opposed to the machine. But it was within that, they preferred the ones that were written after people saw the generated output. So it's really interesting because people are clearly extracting something from the generated output, and there's still more research to be done to understand this process. But it's clear they're not just seeing the generated output and doing a copy paste or anything like that.
Melissa, we have a question in the chat from Les Gessen. Les, you're welcome to speak out. We have a very small gathering, so.
Okay, yeah. Hi, Mo. So this is fascinating. I'm fascinated by this stuff. I did a thing with Markov chain text generation a while back, but this is really advanced. I'm curious, having seen this stuff, like I could see it being used. I'm an advertising copywriter, kind of to prompt ideas. You know, it's never quite what I've seen quite as good as something a real person would write, particularly a real writer. But have you seen cases, or is it approaching anywhere where you go, wow, that's as good or better than what a person would write?
Yeah, I think it really depends on the task. So, and it's for writing tasks that are highly constrained. These models are going to very clearly fail people's Turing tests for that sort of thing. It's when you have one of the things that I think makes these models so useful for creativity is that they can kind of become part of the brainstorming process, in that the final output doesn't need to be a matter of like, okay, here, this is ready to go. It's got the stamp of, okay, it looks human-like. We can just, substitute it in for an actual writer. This is really part of what I see the value in this as being part of the brainstorming process itself, where maybe, yeah, just like with this infilling example, you don't directly use the output, but it inspires you to change your thinking or to go in a different direction that you didn't previously consider. So that's why my work has focused on this particular idea. Of course, there are other tasks where the goal is to just fully automate the writing of, for example, a report. If it's like a financial report or a report about just a summary of events that have happened there. When the task is extremely formulaic, then you see these models being fairly successful, and you don't even really need a very advanced model like GPT-2 that's trained on a bunch of text and has a bunch of parameters. That if the task is simple enough, a relatively simple model can produce something that is acceptable to people. But there's so much complexity to human languages. So as you start to get into more open-ended tasks, where there are clear expectations that people have about the final product, that's when the models will kind of fail people's expectations there. Right. So all of the work I do, though, is not really about pushing AI as being something that can produce a creative final product, but it being a collaborator in that process.
I like that. I mean, I'm fully interested in that.
Yeah.
One of the things I do see is things that are kind of more like Madlibs, like templated kind of stuff. And I don't know if that's in this same realm or not.
Yeah.
Like a box score, obituary, those kind of things that are basically a form. And I don't know if this is pulled from a database and put in a word, or if it just if it's capable of just organizing language to do those kind of things.
Yeah, you could absolutely apply this model to Madlibs. It is really interesting because the reason that that's entertaining is that you don't have that contextual knowledge when you pick out those words, right? And then when you insert them, the combination is suddenly like, oh my gosh, that's a meaning that I did not expect to encounter.
Right.
And that's what I see the value of these models in that the system isn't sharing the same knowledge that we have. It's not making the same assumptions, and that can actually end up producing something that's really surprising to us that then takes on value because it's so surprising.
Yeah, I love that aspect of it, particularly, because like I say, I'm an advertising copywriter who's fascinated by this stuff, and I program some, and I'm trying to do more of this. But what I see happening, if you write creatively, you're trying to come up with ideas. Sometimes you're working for weeks on this thing. And there's a great metaphor by this guy who writes about creativity, Edward de Bono, and he talks about, if you like, creativity is kind of like, what happens is when you're brainstorming it's like water on a dirt plane. at first, you know, it's kind of going everywhere and it's really good. And then the more water you add, it ultimately comes like these rivers, these sort of ravines that the water gets stuck in. And I think that's a really hard part when you're brainstorming for weeks on end on stuff is you'll talk to people the first day and they're really fired up. A week later, they're just staring at each other. And I almost see this like a junior copywriter who has a lot of really bad ideas, but occasionally gets a home run, you know?
Yeah, absolutely. And that gets at a really important research question is, you know, that being where are these tools most useful as far as the entirety of the creative process? There's certain times when a human writer just wants to be fully in control of what they're writing because they already have something that they want to run with and they don't need any interference from an automated system. They already have an idea nailed down. You can imagine this being more useful in situations where people, you know, don't have an idea. I mean, the original motivation behind creative help was, you know, the way we thought about it was to help people get unblocked who have writer's block.
Right. Absolutely.
Yeah. And so there's times when a part of the research here is figuring out what is the appropriate time at which these systems should contribute to the writing process. So, and that's still an open question of like, when we design interfaces for these things, we want these things to respect the constraints or the process at which the timing at which they move. So, you know, that's another issue to be figured out.
Interesting. Yeah, there's some really cool exercises because if you have to do this sort of marathon of creativity where you just can't think about stuff anymore. So you'll do things to kind of jog your brain. Like you'll go, okay, I'm gonna pick up a random book, whatever the 19th word is on page 26, I'm gonna brainstorm off of that. Not so much necessarily to have that be a good idea, but to jolt you out of those ruts. And
absolutely.
And then, or somebody walks into the room sometimes and goes, have you thought about, and they haven't been working on it, right? Because they're not stuck in that rut. And I think that's just a great use of this stuff.
Yeah. And I mean, there's very simple examples of this that are not digital. So actually some of the data that's been used to train these story generation models, and it relates to I showed one slide with the flash fiction, if you can see that. So this comes from, this task was motivated by the Reddit, the subreddit writing prompts. It's actually what it's called. So that people post, you know, some premise for a story, and then all of the responses are stories that elaborate on that premise. And I mean, you could see this as just a very simple way to get, you know, the ball rolling on how to write.
Right.
Starting a story in the first place. So just providing, even though, you know, that's not even, this is all just like human managed, just giving people a seed for what could actually come out of that. This is what these digital tools can also facilitate as well.
Have you seen this movie written entirely by AI? It's terrible. It's awful.
Sunspring.
What?
Is it Sunspring? I have.
Yes. It's good because it's so bad, you know, and it was really done before GTP2 and all this kind of stuff too, you know. But it's just terrible, but it's kind of funny. But I have seen other people, I just moved out to Detroit from LA, but I have seen other businesses trying to have it write script. I haven't seen them do it successfully.
Sure. So Sunspring, yes, actually the time it came out, if you go to the demo for creative help for the story continuation stuff, you'll actually see it actually resembles a lot of the things that were uttered in Sunspring. So it is a slightly different model than, for example, the infilling stuff, and because it doesn't use GPT-2 and it's not as large. So you have that same like strange kind of surrealist absurdity sort of effect that's going on. And this is certainly still the case with GPT-2 as well, where it's just kind of like, wow, that's weird. There are many outputs where you're like, that's just strange. And that doesn't follow from the context. I mean, again, I see a lot of value in that, but it's all just based on your expectations. If you don't, you know, you wouldn't bring the same set of expectations to watching Sunspring as you do to another movie. And so there's value in it, but really because of its degree of absurdity. At least that's how I see the value.
I think so too. And I think actually the more absurd and like poetry, it does well because you're not expecting it to have this logic to it. It doesn't
Exactly.
it doesn't seem to
Yeah.
do cause and effect very well, but it can
Yep.
do lyrics because, you know, lyric could make absolutely no sense a lot of times, you know.
Exactly.
Like I saw a great thing somebody did where they had it make band names for Lollapalooza.
Yeah.
And so that thing you were talking about where it kind of crashes names together, they
Yep.
were fantastic, you
Yep.
know, or colors for paint,
Exactly.
you know, stuff like that. And I do think that's where it could be actually useful in naming. Like sometimes I've had assignments naming products and stuff like that, you know.
Yeah, exactly. It's all about what are the expectations and the requirements for the task. And so certain language generation tasks will lend them, or these models will work better or will facilitate certain generation tasks better than others. So we absolutely have to keep that in mind. You know, what is the task that we're actually trying to accomplish? And so, and will an automated model, how will an automated model help us accomplish this?
Okay. You know, I'm really fascinated by this. I appreciate you doing it. And is there, are you going to leave some kind of link where can I connect with you on Twitter or something like that to follow?
Yeah, Twitter or LinkedIn.
Okay.
I'm on LinkedIn. Yeah.